Hey everyone, today we're going to look at inequalities and we'll go through a few examples. Hopefully that should be enough to get you started on this concept. We'll begin with the inequality x is greater than 7. So this is symbolically how we write that. X is greater than 7. Verbally, x is greater than 7. And instead of always writing, even kind of becomes intrinsic after a while, but instead of always just writing is greater than, we come up with a symbol, and the symbol can be somewhat complicated, but directionality and orientation is important here. So if I want to say x is greater than 7, I don't know how you would have learned when you were younger and you looked at these types of symbols. I've kind of just memorized it as this particular, I guess, open side is bigger, so x is bigger than the other side, which is 7. Now, that's the idea of an inequality. Another example would be x is less than 4. So kind of like example 1. Example 2. So x is less than 4. We can see this in a couple different ways. We could see x is less than 4 written like so, or alternatively x is less than 4. 4 is greater than x. Usually if I am trying to describe it in terms of the variable, I always flip it around to look like this, because we often read left to right in math. And so if I want to say what's x, if I had this, I would flip it around just so that I could be sure that x is less than 4 and kind of read that left to right and not get tripped up on that. We'll try one more. Example 3. X is greater than. I hope you remember what this particular line underneath means. If I say this, it's x is greater than or equal to. So x is greater than or equal to -2. So let's write that down. X is greater than or equal to -2. Okay, so those are kind of the basics. Let's take a look at maybe a type of question that we could have here. So let's say give 2 values of x that satisfy x is less than or equal to -2. So what are 2 values of x that satisfy that inequality? Well, you have to say, well, what is a number less than -2? Okay, so x being equal to -4 would satisfy the inequality x is less than or equal to -2. Another value that would satisfy the inequality would be x is equal to -2. When we say x is less than -2 or equal to -2, the value of x -2 satisfies that. So it's an or statement. So it can be less than -2 or it could be equal. So these are 2 values that satisfy. Just by comparison, what does not satisfy the equation doesn't satisfy. This could be considered to be something that doesn't meet the criteria of being less than or equal to -2. So for example, x is equal to 0 does not satisfy that inequality. So that's one kind of be asked to give two values that do or perhaps don't satisfy the inequality. Another way that we represent this information is by graphing the inequality on the number line. So let's graph the inequality x is greater than or equal to 0 on a number line. So here's a number line. If we want to graph the representation of x being greater than or equal to 0, how we represent that is simply we start at 0. If x can be equal to 0, which it can in this case, we shade in that dot where we start, and then we draw an arrow to everything that would satisfy that inequality. So the arrow pointing to the right means it continues onward. So 1 is greater than or equal to 0, so it's 2, so it's 3, so it's 4, so on and so forth. Okay. Alternatively, let's graph the inequality x is less than -2. So let's graph that inequality. In this sense, we'd have our number line. Perhaps we'll say 0, -1, -2, -3. For a number to be less than -2, it would be to the left of -2 on these number lines. So draw a circle, and if it were to be less than or equal to, we would shade that circle. Since it's not that, we leave the circle as an open circle and draw our arrow like so. Okay, so I hope this is making some sense. There's one more example that I'd like to go through for graphing, something you'll see as you move on through high school. How would you represent that x is greater than -3 but less than or equal to 4? So when I read this left to right, I'd say -3 is less than x, but x is less than 4. That can be somewhat confusing. I like to start in the middle with these types of inequalities and say x is less than 4, less than or equal to 4, but also greater than -3. I'll also find myself saying that x is in between -3 and 4. So our number line might look something like this. Here's our 0, 1, 2, 2, 3, and 4. -1, -2, -3. Okay, so I can be kind of like this. I can be equal to -4, so that's a closed circle or a filled in circle, but I cannot be equal to -3, so I'll say this, and then everything in between is okay. In other words, is 0 both less than or equal to 4? Well, it's less than, so it's 0 satisfies that. Is 0 greater than -3? Well, that's also true. So that's kind of why I read this as x is in between negative 3 and 4. But it's not allowed to actually be negative 3, whereas here it is allowed to be 4. I hope that makes sense, and that should be everything you need to know for inequalities.